Lesson 6 is distance in the coordinate plane, and in 6.1 we're going to find the distance between 2 points on a coordinate plane using Pythagorean theorem. So Pythagorean theorem was that formula a squared plus b squared equals c squared that we got to use to find a missing side for a right triangle. So with Pythagorean theorem, with the formula, the only thing that really has to be true is that a and b have to be the legs, which are the two shortest sides of the triangle, and then c has to be the hypotenuse. So let's say this would be side A, side B, the two legs are the ones that kind of help create the right angle. And then C, the hypotenuse, is the is the side that's across from the right angle always. And it's also always the longest side of the triangle. Okay, so example 1, use Pythagorean theorem to find the distance between point A and point B. So usually we use Pythagorean theorem to find a missing side of a triangle, and on this graph we just have 2 points, but we can create a right triangle between those 2 points by drawing a vertical line, horizontal line, and then connecting the 2 points. So you can actually draw it a couple different ways. One way is by going up and then over and then connecting, or you could do it the other way as well. You can go over first to the right and then up and then connect. And regardless of which triangle you use, you'll end up getting the same distance. So you can't draw the triangle wrong unless you drew something that wasn't a right triangle. And then we're trying to find the distance between A and B, so this side, and that side is the side that's across from the right angle, so that would be the hypotenuse. So that'll be C. And then now if we're trying to find the hypotenuse, we have to know the 2 legs. You have to know 2 of the 3 sides to use Pythagorean theorem. So you can find it a couple of different ways. One is just by counting how long the sides are. So this is 1, 2, 3, 4 units. And then the other side is 1, 2, 3, 4 units. So that's one way. That always works when you have a graph in front of you. I want to show you one other way because it kind of builds up to what we're going to do in 6.2. So the other way is by subtracting the coordinates of the points. So point A is -2, -1, and then point B is 2, 3. So if I want to find the side of the triangle that goes side to side, so this one goes left and right, I have to subtract the x coordinates. And anytime you want to find the distance between 2 points or 2 coordinates, you just have to subtract them. And then because we're dealing with a distance, we're also just going to kind of take the absolute value of them. So it'd be the absolute value, which the absolute value, if you don't remember, is it turns everything positive. So it'd be the absolute value of 2 minus -2, so 2 minus -2, or you could order it the other way. It doesn't really matter. You could do -2 minus 2. It'll have the same outcome because you're taking the absolute value. And then anytime you have a double negative like that, so 2 minus -2 would turn into 2 plus 2. So that'd be 4. The absolute value of 4 would still be 4. And then to find the side that goes up and down this side, you would have to subtract the y coordinates. So we do 3 minus -1 or -1 minus 3. Really, again, the order doesn't matter. So let's say for this one, I changed the order. I did 3, or sorry, switching it. So -1 and then minus 3. The order doesn't really matter because I'm taking the absolute value. So -1 minus 3 is -4, and then the absolute value of that is +4. So you end up getting the same distance as you count on the graph, but this really kind of knowing to subtract the coordinates builds up to the distance, or the distance formula, which is what we're going to use in 6.2. Okay, so now if we want to find the distance between A and B, point A and point B, using Pythagorean theorem, we just have to put one side in for A and then one side in for B. Really doesn't matter which is which, especially now because they're the same number, but a squared, I'll just rewrite the formula first, but it'll be a squared plus b squared equals c squared. A is going to be 4, b is going to be 4, and then we'll solve for c. So it'll be 4 squared plus 4 squared equals c squared. One of the more common mistakes with the Pythagorean theorem is people want to just add the 4's together and make it 8 squared. That's a big no, can't do that. Because if you think about order of operations, which that's PEMDAS or GEMS, there's like different ways of thinking it, you would simplify exponents way before like addition. So you can't add before you simplify the exponent parts. So we got to square each 4 individually. So 4 squared is 16 plus another 4 squared, which is also 16, and then equals c squared. And then 16 plus 16 is 32 equals c squared. And then we want to get just c, because like the hypotenuse is not c squared, it's just c squared is the thing that's in the formula. So now if I want to get just c, I would have to square root both sides. And then we're just going to leave it in like simplified radical form. So what that means is if you have a like perfect square factor of 32, you can take the square root of that. So even though like 32 you can't take the square root of, you can simplify a perfect square factor. So like 32 is 16 times 2. So that means that you can take the square root of 16 and you could take the square root of 2 separately, and then that'll give you like your simplified radical form. And I'll show you another way of simplifying them after we finish the problem. So the square root of 16 is 4, and then times the square root of 2, that can't be simplified. So we're left with c equals 4 times the square root of 2. Okay, and then the other way of simplifying radicals, let's say like you have a number it's kind of hard to think of the factors of, is you can make a factor tree for it. So like say we have 32, and you can pick any 2 numbers that multiply to 32. So like let's say we did 4 and 8, and then you'd keep breaking the numbers down until you get to prime numbers. So like 4 would be 2 and 2, 8 would be 2 and 4, and then 4 would be 2 and 2. So now like all the 2's, like the leaves at our bottom, those are the primes. And of those, we're looking for like pairs of the same number. So I have a pair of 2's right here, and I have a pair of 2's right here. Any pairs like get to come out and would get multiplied together. So we would take like a 2 from right there, a 2 from right there, multiply those 2 to get 4. And then any number that's not a part of a pair gets left inside the radical. So that last little like straggler 2 gets left in the radical, and that ended up being the same answer as we got before. So 4 times the square root of 2 is how the square root of 32 simplifies. So moving down to 6.2 is the distance formula. So given any 2 points in the coordinate plane, A, which is x1, y1, and then b, which is x2, y2, the distance between the points is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And this formula is pretty much just a reworking of the like Pythagorean theorem. It's just has like the distance kind of isolated, and then it actually has like the places for each point in there, so that it's a little bit easier to do without actually having a graph in front of you. So before we get started on the example, I just want to like show you how you can kind of get from Pythagorean theorem to this formula. You don't have to write this down, but it's just kind of like nice to know. So Pythagorean theorem is a squared plus b squared equals c squared. So if I were to take this formula and start to isolate just the distance, well, in our like problem above, the distance was c, and that's always going to be the case where we're solving for like the hypotenuse, the distance between the 2 points. So if I wanted to get c by itself, I would have to square root both sides. And then I'm just going to move the c to the front now, so it'll just be regular c, not c squared, equals the square root of a squared plus b squared. And then if we look back at how we found each side, so we found a, that was this side right here, the one that's highlighted in pink, by subtracting the 2 x coordinates. So like 2 minus negative 2. So that's like my, instead of a, I could write it as, I'm gonna move over the squared, but I moved over too much. Okay, so instead of a, I can write it as like that difference, because that's exactly how I found a. So it's x2 minus x1, or it could be x1 minus x2. That order doesn't matter. And then for b, that's the side that's highlighted in blue that we found up here by subtracting the 2 y coordinates. So we did like negative 1 minus 3, and again, order doesn't matter as long as you're subtracting them. So instead of b in that formula, I can replace it with y1 minus y2. And then we don't even really have to put the absolute value bars in there like we did before, because we're squaring both of them. So like if I subtract something and I square it, it's going to turn it positive. If I subtract something and square it again, it's going to turn it positive. So no matter what, like when you take a quantity and square it, it's going to end up having the same outcome regardless of like the original quantity was positive or negative. So like -2 squared has the same outcome as 2 squared. They would both be +4, since a negative times a negative would be positive. Okay, so now you could see like how the Pythagorean theorem, like the way that we reworked it with like organizing the coordinates, it looks just like the distance formula. It is the distance formula, it's just made so that you can use it like a little bit more easily without actually having a graph in front of you. Okay, so example 1, find the distance between d, which is -1, 5, and e, which is 7, -12. So the distance formula is really forgiving in that it doesn't matter which one is your 0.1 or your 0.2, because when you subtract them, like subtract the two numbers, regardless of which one you put first, like after squaring it, it's going to end up being the same. So like let's say, for example, one of my numbers is 5 and one of my numbers is 3. Well, if I subtract those and then I square them, 5 minus 3 is 2, and then 2 squared is 4. But if I switch the order, 3 minus 5 is -2, and then if I square -2, it still ends up being +4 because you're multiplying a negative times a negative. So it doesn't matter if you mix them up. The only thing that you can't really mix up is like the x's and the y's. So make sure that x's go in the x spots and the y's go in the y spot. So I'm going to say that d is my 0.1 and then e is my 0.2. So I'll make this my x1, and then my y1 will be 5, and then x2 will be 7, and y2 will be -12. Again, it really doesn't matter which way you like kind of work it, it should always end up being the same. Okay, so x2 was 7, so that'll go right there, and then x1 was -1, so that'll go right there. Be careful with the double negative. And then y2 was -12, and then minus y1, which was 5. So it'll be d equals big massive radical. So x2, that was 7, and then minus, and then x1 is -1, so it'll be minus -1. And then you got to remember to square it, and then plus y2, which is -12, and then minus y1, which was 5. So just always be careful with the minuses. Remember, you have like the minus in the formula itself, then you could end up with a double negative. Okay, so in the kind of first set of parentheses, 7 minus -1, remember when you have like a double negative like that, it turns into a plus. It's like saying the opposite of -1. So this will be 7 minus -1 will turn into like 7 plus 1, so it'd be 8 squared. You don't really need the parentheses anymore because it's a positive number. If you want to keep them, you can, though. It's not like wrong to have them there. And then on the second set of parentheses, -12 minus 5, it's like you're starting at -12 and then you go down 5 more, so you'd be going down to -17. So this would be -17 squared. And then from there, we do need to square them separately, just like the Pythagorean theorem, so we can't like just add them together and then square after. So we got to square first, so it'll be 8 squared, so 64. And then -17 squared. You don't really have to worry about like negatives when you're squaring, because a negative times a negative is going to be positive, so you can just do 17 times 17 if you're not sure what the square is. And it'd be 289. So -17 squared would be 289. And then now we can add that to the 64. So it ends up being d is the square root of 353. And then this one we're going to get a like decimal approximation for. So if you are using like a phone calculator, you have to turn it sideways to get the radical up there. But you type in 353 and then take the square root of it, and it should be about 18.79. So the distance between those 2 points is approximately 18.79. And then it's always like good practice to just kind of make sure that like it makes sense in context. So like look at your points and see like, okay, do they look like they're really close together? Do they look like they're a good distance apart? And like our x-coordinates, just our x-coordinates are from -1 to 7, so that would be like 8 units apart. And our y-coordinates are like from 5 to -12, so that'd be like 17 units apart. So that 18.79 seems like practical. And the distance, remember that the distance between the 2 points is your hypotenuse if you were to draw a triangle. So the distance from between the 2 points should be longer than the distances between just the x's or just the y's.